Hello everyone. Welcome into Coding with Zahara Bidin. This is the second session of face mask detection module. Yeah, that's the content of the presentation, and we shall start right away with the introduction. Like in the year 2020, a global human-made virus called Corona hit the world, and this brought about a variety of changes, such a way that all continents were affected. And the result brought a change in the people's living situations, which brought up a new normal that included putting on masks, those are the face masks in the public places. This was also followed by other diseases like Ebola and all other respiratory diseases that also needed putting on face masks in some few countries, especially Africa, particularly Uganda, because it's a current ongoing situation. And as an IT student, as we use IT to change the world, here I come up with a solution of a face mask detection model that can help with other respiratory, like to prevent the spread of other respiratory diseases as well. The problem statement is the problem of monetization of individuals in the public places to put on masks has become so costly and hectic due to the employment of a variety of security personnel also to observe, to help the people observe the rule of putting on masks to prevent the high spread of diseases like COVID-19 and other deadly respiratory diseases that can be prevented and can be prevented through the putting on masks. The dataset that I obtained is called a face mask detection dataset, which was by Luxel, which contained 7,553 images that shall be used in our solution that shall be used by AI to solve the problem. 3,725 of these images have masks and are labeled masks, and those that are labeled without masks are 3,828 images. Since the comparison is between those who have masks and those who do not have masks, this will be helpful in training our model to check whether the people who have masks are different from those that don't have masks. And therefore, if it's trained, it can be very easy for it to identify that person who is not putting on a mask and that person who is putting on a mask. The factors that I considered before selecting this dataset, I considered validate completeness. This was making sure that all the necessary data required is in the dataset. And it was fully having all the necessary data that I needed. Then the validate consistency, which was making sure that all the data is the same and not mixed up, like finding images with masks and those without masks all in the same level. It was not the case. So the validate constraints, making sure that the data has constraints for its own data. If at all I've labeled a label with mask, it means every image in that label should be putting on a mask, and those without, every image in that label should not have a mask. Then validate uniformity, making sure that all the data are the same unit measure. Since I'm dealing with images, so all the data are in pixels. The important features that are identified to be used by AI in this dataset were face images with masks, face images without masks, and those who are putting on masks improperly. When you talk about the Bayesian theorem, this is a mathematical theorem for determining conditional probability. When I talk about conditional probability, conditional, of course, something that is timed. Like, let me say, students at school, there is ringing of a bell. So we have a probability of those students who will respond to the bell, and the number of students of those who will respond to the bell and those who will not respond to the bell. So it's conditioned. The probability is conditioned, and that's the formula for the Bayesian theorem, and properly explained with its contents. Then the naive Bayes is a machine learning algorithm we use to solve the classification problems. It's based on Bayes' theorem. It's one of the simplest yet powerful ML algorithms in use and find applications in many industries. Therefore, it's so useful and it's dependent on the Bayesian theorem. The Bayesian networks, these are the networks that are type of probabilistic graphical model. In other words, they also depend on probability to come up with those graphs that can be used to build models from the data or expert opinion. They can be used for a wide range of tasks like anomaly detection. When we talk about anomalies, I think we can have the insertion anomaly, the deletion anomaly, and we find that all in the data when dealing with the data to be stored in the database. Yeah, even diagnostics and etc. And the differences between Bayesian theorem and naive Bayes, it's these two things are nearly equal, but then here comes a small difference between them. When we look at the naive Bayes, it assumes conditional independency. When we talk about conditional independency, every input that we put in is self-dependent. It doesn't depend on any other, which is not the case with the Bayesian theorem. And that brings about the difference between the two terms. Then the difference between the naive Bayes and the Bayesian networks are the Bayesian networks are probabilistic graphical model that uses Bayesian inference for probability computation. And the naive Bayes is a probabilistic classifiers based on the application of the Bayes theorem. Of course, I've already talked about the naive Bayes, which is a probabilistic classification. It classifies data. Like since we are dealing with big sums and large sums of data, we usually need to classify that data for proper learning of our machine, for proper training of our machine to get adapted to that data. Data that is classified, when it finds such data, it cannot make a mistake of identifying it wrongly since the data has been classified, and therefore it can be very easy for us to train our model. Those are the references to the work. What is the simple presentation I had for you today? Thank you for listening. Like, share, comment, keep in touch with us. Thank you.